Hello guys. In this video, I want to talk to you about the difference between quantum physics, quantum mechanics, and quantum field theory. Okay, so this difficult and profound branch of modern knowledge, known as kind of quantum physics, started at the beginning of the 20th century with the work of Max Planck. So he essentially analyzed, spectra, like essentially the heat that gets released from a black thing when you heat it up, and he found some things that didn't make sense, and the only way that the math did make sense was by quantizing energy. Okay, so like essentially saying that energy is not a continuous, kind of spectrum, but it's made out of discrete pieces. Okay, and these pieces were called quanta. So whatever has to do with these super teeny tiny little bits of energy is called quantum physics. And in this respect, both quantum field theory and quantum mechanics, they're both quantum physics, because physics embraces everything. And inside physics we have kind of subdivisions. Okay, so at first, once this sort of idea for quanta was proposed, then it got formalized. Like it was kind of advanced, and the concepts of mechanics were applied to it. And the greatest genius to make a contribution in this regard was John von Neumann, a Jewish Hungarian mathematician. Definitely one of the greatest mathematicians ever, and he kind of formalized quantum mechanics into this, quantum, concepts into this, mechanical, into this language of mechanics. Okay, so that's what quantum mechanics is. However, quantum mechanics just deals with kind of particles as they are by themselves, and it doesn't deal with a very fascinating aspect of this whole story, and that is how do these particles come into existence and how do they die? Okay, how are they born and how do they die? Because like things like Schrodinger equation, all these Lagrangians, Hamiltonians, all these mechanical concepts, they don't really, um, you know, deal with how particles are born and how they die. And that is what quantum field theory, does give you the answer to, how particles come into existence and how they go out of existence. So essentially, quantum mechanics plus, birth and death of particles gives you quantum field theory. So in quantum field theory, particles, these electrons, protons, well, not protons, but more fundamentally, quarks, they're just excitations in the quantum field, okay? And, it describes how the quantum field gets excited and, different conditions, when it happens and when it doesn't happen. Definitely one of the hardest, things to learn. The mathematics is extremely complex, extremely difficult, but it's really, really interesting stuff. So, uh, and kind of the latest, development in quantum field theory is this controversial, theory known as string theory. Okay, it, kind of says that, at the most fundamental level, the world is made out of these tiny little strings of energy which vibrate sort of their the excitations in the field, and it's even it's much more difficult than quantum field theory. And string theory is essentially the latest development. And unlike quantum field theory, string theory has not been tested in any way whatsoever so far. So it could be literally the greatest, profoundest thing that humans have ever thought of, or it could be just a mathematical theory which has nothing to do with reality. Which one is it? I don't know. And as of right now, no one else does.